Hi everybody. In this lesson we're going to look at horizontal translations and vertical translations of the sine and cosine functions, and we're also going to graph several functions that are a combination of different translations. First of all, we hardly ever actually use the words horizontal translation. We usually just call it phase shift for short. In the graph of y equals a sine of bx minus d, the b and the d both affect phase shift. We saw last time that a affects amplitude. We saw that b affects period. But now we're going to see that b and d both affect phase shift. And also the phase shift goes the opposite direction from the sign that you see in the function. When you look at a function and you see bx minus d, that is going to tell you that the phase shift is actually going to the right. And when you look at a function that's sine of bx plus d, that plus sign tells you that the translation is actually to the left. Both of these assuming b is positive. And now we want to see why that sign is backwards. We know from what we saw before that when you graph y equals sine of x, the period is 2 pi. That means that as x goes from 0 to 2 pi, the sine of x goes through one cycle. Well, when you have y equals sine of x minus d, it has to go through one cycle as x minus d goes from 0 to 2 pi. So what happens is, to find the phase shift, you take the argument, which is what's in parentheses here. Argument means what's being plugged into the function. Take the argument and set it equal to 0, and that will tell you where the pattern should start. And then when you solve, that's going to involve moving the d to the opposite side of the equal mark, and that's going to involve a sign change. So you take the argument and set it equal to 0, and add d to both sides, and you can see then that d comes out positive, and there's your sign change. See, if we have x minus d, the minus sign means we're going to end up with a positive d when we solve, and that means your phase shift is to the right. So the phase shift tells us where to start the pattern for our graph. Now, to find the label of the tick mark at the end of each cycle, all you need to do is take the starting point for that cycle and add a period to it, because each cycle is one period long. Okay, so we're going to graph y equals sine of x minus pi over 3, and we're going to do 2 periods. First of all, notice that amplitude, or a, equals 1, so that means amplitude equals 1. Also notice that b equals 1. Remember, b is the coefficient of the x term, and if b is 1, that means period is 2 pi. Okay, now for the phase shift. What you're going to do for phase shift is take what's in parentheses and set it equal to 0, and now solve. So we'll add pi over 3 to both sides, and we see that x equals pi over 3, which means that phase shift is to the right. Now look, you can look here and say that this is a minus, so I know the sign is backwards here, and so that means that the phase shift is going to be to the right. Or after you solve it, the sign will be correct, and you can see that the sign is positive, and therefore we're shifting to the right. Now let's go ahead and calculate the label that will go at the end of the first cycle. So the first cycle is going to start at pi over 3, and it's going to be 2 pi long. So we're going to do pi over 3 plus a period, and now we need a common denominator, so 2 pi is equal to 6 pi over 3. And now add your starting place plus your period, and that's going to be 7 pi over 3. So that's the end of the first cycle. Now the second cycle will start at 7 pi over 3, and we'll go another 2 pi, so add another 6 pi over 3, and that'll be 13 pi over 3. Okay, now we have all the information we need to label our axes. I'm going to go ahead and label the vertical axis at positive 1 and negative 1, because that's our amplitude. And then my starting place, I'm just going to put a mark here to the right of the y-axis, and I'll call that pi over 3. Now I'm going to make 4 evenly spaced marks, and this one is the end of the first cycle, and so that's going to be our 7 pi over 3, and then 4 more evenly spaced marks, and then this one's going to be 13 pi over 3. Okay, now for the pattern. We know this is a sine pattern, and the sine pattern goes middle, high, middle, low, middle. So middle, high, middle, low, middle, and then go ahead and repeat the pattern. And then you can connect the dots. And there are 2 cycles of the sine of x minus pi over 3. Okay, let's do another one. So here we have y equals 3 times the cosine of x plus pi over 4. And again, we'll do 2 periods. So always start by analyzing your a and your b. So in this case, a is 3. That means amplitude is 3. B is 1. And that means period is 2 pi over 1, which is just 2 pi. And now we'll get phase shift. To find phase shift, we take this argument and set it equal to 0. And that means to solve this for x, we're going to have to subtract pi over 4 from both sides. And therefore, x equals negative pi over 4. Okay, now that's to the left. And that's a little bit of bad news, because that means that our starting mark is going to be back here to the left of the y-axis. Now remember last time how I just put a mark out here to the right and then I made 4 evenly spaced marks? Well, it's not that simple this time because the y-axis is in our way, and we don't know where the y-axis is in relation to our 4 marks that we're going to make, but it matters. So what we're going to have to do is calculate the quarter marks. So I'll take my starting place and I'll add a quarter of a period. My starting place plus a fourth of the period, and that will give me my first quarter mark. Now that's negative pi over 4 plus 2 pi over 4, and that ends up being positive 1 pi over 4. Okay, so that's good news because now we see that our first quarter mark is going to be to the right of the y-axis. Alright, let's go ahead and get the labels for the end of the first cycle and the end of the second cycle. So the end of the first cycle will be the starting place of the first cycle plus a period. Now we need a common denominator here, so I'll multiply this by 4 over 4. And we'll see that 2 pi becomes 8 pi over 4. All you're doing is multiplying that by 4 over 4. And now we have negative 1 pi over 4 plus 8 pi over 4 is going to end up being 7 pi over 4. And for the second cycle, we'll take this starting place of 7 pi over 4, add another period to that, and that'll put us at 15 pi over 4. Now, I hope that you're able to add fractions without putting a lot of thought into it. But if the fractions are giving you grief, you need to get your calculator and figure out how to add fractions on your calculator. But you definitely are going to need to be able to add some fractions here. So don't avoid it, and don't be one of those people that just adds numerators together. You have to have common denominators before you can add numerators. Okay, so now we're ready to label our axes. So I've labeled the y-axis from negative 3 to positive 3. And now I'll put a negative pi over 4 back here to the left of my y-axis. And remember, my first quarter mark goes here, so that'll be positive pi over 4. And then what I did was that's my first quarter mark, so then I made my 3 more. Remember, we make a starting mark and then 4 evenly spaced marks. Well, my first quarter mark is the first one of those 4, so then I needed 3 more. So we always have 5 marks for our pattern, right? All of our patterns have 5 marks. So here's my starting mark plus 4 more evenly spaced marks. And this last one is the end of the first cycle, which is 7 pi over 4. And then let's lay out 4 more evenly spaced marks. And this last one is the end of the second cycle, which is 15 pi over 4. Okay, now for the pattern. So this is a cosine function, so the pattern is going to be high, middle, low, middle, high. High, middle, low, middle, high. Now notice that there's not a dot on the y-axis because the y-axis is not where one of our tick marks is. So the dots go with the tick marks, and the axis this time just happens to be there, not doing anything. And then we'll put our 4 more marks, and then we'll connect the dots, and that's it. Okay, now we haven't seen this in an example yet, but remember that B also affects phase shift. So you can't always just look at the D number and know the phase shift. For the sine of bx minus d, if b is not 1, the phase shift will not be equal to this number. You're going to have to set this whole thing equal to 0 and solve to find the phase shift. So if you have any number besides 1 here, if b is not 1, you're going to have to work to find the phase shift. Okay, here's one where we do have a b number that is not 1. So let's very carefully start with a and work our way through. Okay, first we see that a is negative 2. And that means that amplitude is positive 2, and also there's going to be a reflection across the x-axis. Now b is 3. And if b is 3, that means period is 2 pi over 3. Okay, now let's get phase shift. To find the phase shift, you take that whole thing in parentheses and set it equal to 0. Solve for x. And we can see that the phase shift is pi over 3 to the left. Okay, now because it's to the left, I'm going to have to find that first quarter mark again, because when I get ready to lay out my 4 evenly spaced marks, I don't know where the axis should be in relation to those marks. So to find the first quarter mark, we take the starting place, which is the phase shift, and we add a 1/4 of the period to it. The starting place plus a 1/4 of the period. Okay, now in this case, the 2 and the 4 are going to reduce, and that'll give us the 2 pi over 4 times 3 is going to give us 2 pi over 12, which reduces to pi over 6. We'll have to get a common denominator here. Negative pi over 3 is negative 2 pi over 6, and when you add positive pi over 6, you get negative pi over 6. So the bad news is that our first quarter mark is still to the left of the y-axis, and that means that we have to find the next quarter mark. So we'll take our first quarter mark, add another 1/4 of a period to it, and this time we end at 0. That's going to mean that our second quarter mark is going to go right on the axis. Before we start labeling, let's go ahead and calculate the end of each cycle. So to find the end of the first cycle, take the beginning of the first cycle, add a period to it, and that puts us at 1 pi over 3. And to find the end of the second cycle, take the beginning of the second cycle, add a period to it, and that gives us 3 pi over 3, which we know reduces to pi. Okay, so here we are making a mark back here. I'm going to call that negative pi over 3. And then my first quarter mark goes here. I'm going to call that negative pi over 6. And my second quarter mark here, and then boom, boom. So starting mark plus 4 more evenly spaced marks. But this one we already calculated is at negative pi over 6. And this one we already calculated is at 0. And then the last one is the end of the first cycle, and that is pi over 3. And now I'm going to make 4 more evenly spaced marks, and this one will be pi. Okay, now the y-axis. The amplitude is 2, so I've labeled my y-axis there positive 2 and negative 2. Okay, now let's make the dots. This time the y-axis does happen to be one of our tick marks, so our pattern is going to be cosine upside down, so low, middle, high, middle, low, low, middle, high, middle, low, and then repeat the pattern and connect the dots. Now this is one of those things that looks like it makes the problem harder, but it actually makes the problem easier. If your argument is in a factored form, you might think, oh my gosh, it's fixing to be complicated because you see parentheses and brackets, but it's actually good news because they've done some of the work for you. When the b is factored out, that means that d is the phase shift. That means that the effect of b on the phase shift has been removed. So if the argument is in factored form, then phase shift is d, and period is still 2 pi over b. So we actually like to see that in factored form. It means less work for us. Let's do an example where they've got the b in factored form. Okay, here is 3 cosine of pi over 2 times x minus 1/2. A is 3, and that means amplitude is 3. And b is pi over 2, and that means period is 2 pi over 2. And you know that to divide by pi over 2 means to multiply by the reciprocal, and that means that the period is 4. Okay, now let's get phase shift. Phase shift, actually, I don't even have to solve because I just can look here and know that if I set this equal to 0, x will be 1/2. If x minus 1/2 equals 0, x equals 1/2, so the phase shift is 1/2 to the right. And we like it when phase shift is to the right because that means we don't have to calculate those quarter marks because the y-axis will be behind us and not in front of us. Okay, now the end of the first cycle will be the beginning of the first cycle plus a period. So beginning 1/2 plus a period is 4. And if you needed to stay in improper fraction form here, you could. But since these are just some really simple mixed numbers, we'll just stay in mixed number form. So 1/2 plus 4 is 4.5. You know, every now and then you can get away with that. And then if you add a second period to that, 4.5 plus another period puts you at 8.5. Okay, so I've gone ahead and labeled my y-axis with my amplitude. And now I'm going to put a starting mark at 1/2. Lay out 4 evenly spaced marks, and the fourth one will be the end of the first cycle, which is 4.5. Now do 4 more marks, and that puts you at 8.5. And now you're ready for your pattern, which is cosine. So high, middle, low, middle, high. High, middle, low, middle, high. And repeat the pattern and connect the dots. And the more you do this and practice with these, the more you can see that it's just we're doing the same thing over and over. It's very regimented, and it's very much the same thing again and again. But you really do need to sit with a pencil and paper and draw your own for practice. It's much different drawing them yourself than it is getting my math lab to do it or watching somebody else do it. So make sure and do some of these yourself, by yourself. Okay, now let's talk about vertical translations. If you have a C number, a number that's added or subtracted from the function, then that's going to move the graph vertically. You can imagine whatever your function value was, if you just add something to every y value, it's going to move it up, or if you subtract something from every y value, it's going to move it down. So for example, here's just some arbitrary function. If you do that function plus 3, it'll just move that graph up 3 places. If you do that function minus 5, it'll just move the whole thing down 5 places. So translation is up if C is positive, and it's down if C is negative. So let's start out with a simple one here. We've got 3 minus 2 times the cosine of 3x, and we're going to graph over 2 periods. I say this one's simple because it doesn't have a phase shift. But it does have an A of -2, and that means that amplitude is 2, and the negative means there's a reflection across the x-axis. And it does have a B equal to 3 because of this 3, and that means period is 2 pi over 3. And it does not have a phase shift because there's no plus or minus D. And since C is 3, the vertical shift is up 3. Okay, now I want you to think about something a little bit here. If you think about order of operations, you take a function value. In order to calculate this y value, after you have your function value, then you got to multiply by -2, which that's going to accomplish your vertical flip right there, your reflection across the x-axis, and then you shift everything up 3. Now, when I draw it, I'm actually going to do the vertical shift first. I'm going to draw the vertical shift first, but in reality, the way this is calculated, the reflection happens first. So I don't want you to get confused. If we shifted everything up 3 and then we flipped over the x-axis, the graph would be way down here, below the bottom of the page here. So what's really happening is that we're flipping over the x-axis first, and then we're going up 3. Okay, so watch it as I do it, and just know that according to order of operations, the flip has to happen first. And if you're using my math lab to graph, it is very important that you first do the reflection over the x-axis. Then you can put in all your other transformations. Otherwise, it'll flip it in a way that you're not anticipating, and it'll mark it wrong. Okay, let's go ahead and calculate the end of the first cycle. This one's easy because there's no phase shift. So if we start at 0 and we go out a period, then we're at 2 pi over 3. And then for our second period, if we start at 2 pi over 3 and go out another 2 pi over 3, now we're at 4 pi over 3. Okay, now watch how I do this. Remember, I said I do the vertical translation first. And mostly that's because if I don't, I'll forget it, you know. So I go up 3 on my axis and I draw a horizontal line. That gives my eye something to look at so that I'm not constantly trying to look back at the axis. Because if you keep looking at the axis, you'll want to use the axis as your middle line, and you can't this time. So this gives me a middle line to work with. Now amplitude is 2, so that means from here the highest point in the graph will be up 2 and the lowest point in the graph will be down 2. So the down one's easy because I've already got it marked. So if I'm at 3 and I go down 2, now I'm at 1, and I'm going to put a little line there. And so that shows me where the bottom of my graph should go. And I'm also going to go from the middle, I'm going to go up 2 and draw a line there. And that kind of gives me guidelines to go between. Okay, now let's label our x-axis. Remember, we start at 0 because there's no phase shift, so I'll put my first mark on the y-axis and then 4 more evenly spaced marks. And that last evenly spaced mark is 2 pi over 3. And now 4 more evenly spaced marks, and then the end of the second cycle is there. Okay, now the negative cosine means our pattern would be low, middle, high, middle, low, but we're now moving everything up 3. So low is here. Low, middle, high, middle, low. Low, middle, high, middle, low. And then do the same thing again. And now connect the dots. Okay, so you see how I drew the y-axis part first. I drew the vertical translation first. But in reality, the flip happens first and the vertical translation happens last. And that is the way you need to put it in my math lab if you're graphing in my math lab. Okay, here's another one. Now this one has all the bells and whistles. This one has an A and a B and a C and a D. So first of all, A is 2, and that means amplitude is 2. And because A is positive, there's no reflection across the x-axis. B is 4, and that means period is 2 pi over 4, which reduces to pi over 2. Phase shift will take the argument, the 4x plus pi, and we'll set it equal to 0, and we'll solve for x, and we can see that x is going to need to be negative pi over 4, which means our phase shift is pi over 4 to the left, and everybody say yuck because we don't like left phase shifts. That means we're going to have to calculate where the first quarter mark is. And the C is -1, which means our translation, our vertical translation is down 1. Okay, now the end of the first cycle. the first quarter mark. Because we're translated to the left, we'll have to take our phase shift and add a fourth of a period. And so negative pi over 4 plus a fourth of pi over 2 is going to be negative pi over 4 plus pi over 8. Get a common denominator here. You'll have negative 2 pi over 8 plus pi over 8, and that's going to be negative pi over 8. So our first quarter mark is still to the left of the y-axis. That means we'll need to do the second quarter mark. So the first quarter mark plus another fourth of a period brings us to 0, and that means our second quarter mark is on the axis. That's good news. That means we don't have to calculate the rest of the quarter marks. Okay, now the end of the first cycle, you'll take the beginning of the first cycle, add a period, and so negative pi over 4 plus pi over 2 is negative pi over 4 plus 2 pi over 4, and that's positive pi over 4. And for the second cycle, we'll take the beginning of the second cycle, add a period, and that puts us at 3 pi over 4. Okay, now let's label our axes. Our vertical shift is down 1, so you see I've gone ahead and drawn a horizontal line through the vertical shift. Now amplitude was 2, so if I'm at negative 1 and I go up 2, I'll be at positive 1. And if I'm at negative 1 and I go down 2, I'll be at negative 3. So I'll draw my little line, my little guideline through positive 1, and my bottom guideline through negative 3. See, from the center we go up 2, which is amplitude, and down 2, which is amplitude. And now let's lay out our horizontal marks. I've got my first one here, and then 4 more evenly spaced marks. And you see I put the second one on the axis. So 1, 2, 3, 4. That makes this one pi over 4. And then 4 more evenly spaced marks, and that one will be 3 pi over 4. Okay, now the pattern is middle, high, middle, low, middle. So starting back here at the horizontal shift and the vertical shift, put me right here. Middle, high, middle, low, middle. And then repeat the pattern and connect the dots. Okay, now I want to do a couple with you that involve some fractions, and mostly just to show you that the fractions don't impact what we have to do all that much. I mean, you have to be a little careful about how you label your axis, but overall it's not that big of a change. So let's start by analyzing this one the way we've done all the others. We'll start with A. In this case, A is 1, which of course means amplitude is 1, and it's a positive 1, so there's no reflection across the x-axis. Then B is 2, and notice B is factored out, so remember that means that B is not going to affect phase shift here, only period. So B is 2, and that means period is 2 pi over 2, which of course is 1 pi. And for phase shift, we really can just look here and see that since we have x plus pi over 4, phase shift is going to be negative pi over 4, or we could say pi over 4 to the left. And so vertical shift is up 1/2. That's here. And because our phase shift is to the left, let's go ahead and calculate the first quarter mark. So we take our starting position, which is negative pi over 4, and we add a fourth of a period to that. So of course now we have negative pi over 4 plus pi over 4, which is 0. That means our first starting mark is going to be back here somewhere, and our first quarter mark is going to go here, and the rest of our marks will be to the right of the y-axis, so we won't need to calculate any other quarter marks. Let's calculate the label for the end of the first cycle. We take the starting position plus a period, and of course getting a common denominator, pi would become 4 pi over 4, and then negative pi over 4 plus 4 pi over 4 is 3 pi over 4. Then repeat that for the second cycle. So take your starting position for the second cycle, which is 3 pi over 4, add a period to that, and that puts us at 7 pi over 4. Okay, now let's label our axes. Since my vertical shift is 1/2, I'm going to label my whole number 1, but I know that 1/2 is halfway between 0 and 1. And so I put my 1/2 mark there, and I went ahead and put my horizontal dotted line that I can use as a guideline. Okay, now amplitude is 1, so if I'm at 1/2 and I go up 1, I'll be at 1.5, which is halfway in between 1 and 2, right there. And let's put our top guideline there. And going back to the middle, if we go down 1, 1/2 minus 1 is -1/2. So there's my -1 mark. -1/2 will be right in the middle there, and I'll put my bottom guideline there. And so now I'm looking at the dotted lines. When I get ready to make my dots, I'll be looking at the dotted lines and not so much at the axis. Okay, let's go ahead and label the x-axis. Remember, we start at -π/4. So I'll just make a mark here and call that -π/4. Now we found out our first quarter mark goes on the axis. So there's my first quarter mark, 2, 3, 4. There's my fourth mark, and that's the end of the first cycle. So that's 3π/4, and then 4 more evenly spaced marks, and that puts us at 7π/4. Okay, now here is my horizontal shift or my phase shift. My my pattern is sine, so middle, high, middle, low, middle. So starting back here at the vertical shift, horizontal shift, vertical shift, right here will go my middle, and then here will go our high, middle, low, middle, and then repeat the pattern, and then connect the dots. And see, the fractions didn't really impact us all that much after all. Okay, here's one more. We've got -5/2 plus 1 cosine of 3 times x minus π/6. And again, we'll do 2 periods. So A here is 1, amplitude therefore is 1. B is 3, and period therefore is 2π/3. And let's go ahead and get phase shift. Again, we're lucky here because since the B is factored out, we know that this number alone does represent phase shift. So -π/6, remember we shift the opposite direction of the sign that we see in the function. So it's π/6 to the right. And vertical shift is going to actually be down 5/2. Okay, so we don't need to calculate any quarter marks because our phase shift is to the right. So we'll go ahead and do the first cycle. We take starting position plus a period. Now we'll need a common denominator here, so multiply this by 2/2. And that gets you π/6 plus 4π/6, which is 5π/6. And for the second cycle, we'll do 5π/6 plus another period, which we already know is 4π/6. That gives us 9π/6, which reduces to 3π/2. Okay, and we'll go ahead and label our axes. Since our vertical shift is -5/2, that's in decimal form, that's -2.5. So I need to make my center mark here between -2 and -3. I'll put my little horizontal line there for my guideline. And then amplitude is 1. So if I'm at -2.5 and I go up 1, I'll be at -1.5. Put a guideline there. And if I'm at -2.5 and I go down 1, I'll be at -3.5, so put a guideline there. And it's easiest for me if I keep the whole numbers visible, and that way I can see where the half belongs better. Okay, so here are the guidelines for my function. And let's label our x-axis. Here we have a shift to the right of π/6. And then we need 4 evenly spaced marks. The fourth one is the end of our first cycle, so that's 5π/6. 4 more evenly spaced marks, and that's the end of the second cycle, so that's 3π/4. Okay, so now we have horizontal shift, vertical shift, and our first mark, well, here's the center, but this is a cosine function, so it needs to be high, middle, low, middle, high. So from here, high, middle, low, middle, high, and then repeat and connect the dots. And there you go. So now we've done amplitude, period, phase shift and vertical shift, and we've done reflections across the x-axis. And really, if you'll just very methodically analyze each one, write down what you're doing. Don't try to keep it all in your head. Always write it down, make your calculations, be careful adding your fractions together, make sure you use common denominators. All of these are very similar, and you just need practice. And again, I know I said it before, but I'm going to encourage you, get a piece of paper, get a pencil, and maybe a ruler to draw your coordinate system with, and just practice out of the book and draw them yourself. And don't rely on just watching me draw them or somebody else draw them, and don't rely on having the computer do them if you're working in my math lab. It really will make a world of difference if you'll sit down with an actual pencil and paper and draw them yourself, and you'll get to understand them better than you thought you could. So good luck, and reach out to your instructor if you need any help.